So we have a solution, but by no means is it an elegant solution. Can you identify the ways in which the solution is not as elegant as it could be? Pause the video, think about it, try to change it. See if you can make something better than what I can, and then come back. So the first thing that is bugging me about the solution is all of these special conditions here. It's like we've taken the first step of our loop right here and we've shoved it out here. We're starting count out at 1 because we start with 2 to the 1, and then our power starts at 2, and ideally our power would start at something besides 2, and then because it goes 2, 4, 8, 16, I need something prior to 2, something before 2. And then we have this add out here, which is doing this first add, which is not consistent with this add. And okay, that's a headache. And then, let's see, let me erase this part at least. We have the duplicate next power code, 4 lines of it, in fact. Next power, like so. And then we're also moving some values around. We saw where we did some moves and then didn't change anything. But I'm not sure how worried I am about that. And then another issue I have with this is, what if I wanted to change the base? Alright, we have 2 to the 1 right now. What if I wanted to change it to 5 to the 1 and 5 to the 2 and 5 to the 3? Well, I'd have to come down here and change a 5, which is fine, but then, I also need to remember to come up here as well and change this to a 5. So now I need to update my code in 2 locations, and that's going to offer some maintainability headaches, and I most likely will introduce bugs, that sort of thing. I just want to be able to change 1, 2 to a 5 and be done. So there's an issue as well. And then, what if I asked you to calculate 2 to the 0? Alright, well, we actually would get to 2 to the 3 before we'd finally do our comparison and say, hey, are we less than? And so our code doesn't stop at anything below 2 to the 3. And then if I asked you to go 2 to the 4, well, really, let me see if I can find it. This code does 2 to the 4, but then we don't check to see if we should stop at all. We go on and do the multiplication to 2 to the 5th. So I can't do odd number powers or even number. I can't do even number powers the way we currently have our code, because each iteration of the loop does 2 powers, not just 1. So, that's a headache. And then, again, if I asked you to do 2 to 0, anything to the 0 is a 1. And our code would definitely not do that. It would get up to 2 to the 3. It wouldn't even stop at 2 to the 1. It would go all the way to 2 to the 3. So, lots of issues. How do we fix them? Pause the video, come back, and I'll show you I probably won't address all of them right now, but we'll see if we can knock out a few of them. I think out of all those issues, the first one, the easiest one to tackle would be, let's get this first part of our loop inside the loop instead of having it outside the loop. I want this operation to be inside the loop. Right now it's outside the loop. The rest of this is in the loop, but this operation itself is outside the loop. I want to move it in. Okay, and ideally our count would start out at 0. Okay, because we're going to start out at, you could think of it as 2 to the 0. And then our power, I want to start that out at 1. You can see I've inserted this little 1 right here. So our power is going 1 times 2 times 2 times 2 times 2 times 2, so on and so forth. I want our power to start out at 1. Well, having said that, this addition right here actually needs to change to a multiplication. If you notice, our pattern here is plus, multiply, plus, multiply, plus. And before we were trying to do this plus thing, but when really we should be multiplying in. Even though it's our first iteration of the loop, we multiply plus, multiply plus, multiply plus. And if we set up our state correctly before we enter into the loop, then doing a multiply first should work out quite nicely. We've already begun to set up our state by saying 0 and 1 here. We no longer need this add here. That was kludged as well. We're initializing EBX to our base. Notice we only need to say 2 here. We don't have to say 2 in both places now. We're saying 2 here, and then 2 times 1 will be 2 to the 1. And if I change this to a 5, then it'll be 5 times 1, which is 5 to a 1. So that works out quite nicely. We're going to 0 out our total, our ECX as well. But now we need to do a multiplication first before we do anything else. So our multiplication piece, this operator right here, is down here towards the bottom of our loop. So we basically need to trade this code with our addition. We're going to do the multiply first and then the addition. Let me grab this code, Control X, go up here and paste it over the add, and line this back up. Grab the add, put the add down here. I just swapped our multiply and our add. And you might think it is just as easy as I made it to move these around, when actually there's an issue with what we've done. And can you discover what the issue is? Let me just prove to you there's an issue. I'm going to hit F11, which will save and build. Bring up our code, and you remember our end result here. If we didn't break anything, we should still get 800 when the loop is complete. All right, and that will be in our total, which is ECX. So let's Control Alt D, bring up the disassembly, F11 into our code, scroll down to the return, put a breakpoint there, hit F5, and I'm going to be watching this value right here to ensure that it changes to 800, so to make sure it's correct. So F5, and it is not 800. You know, the problem with computers these days is that they do exactly what you tell them to do, and that can be extremely frustrating. And you know, you always think that, oh, it's the computer's fault. That's not the computer's fault. The computer is an idiot. It does exactly what we tell it to do. Why are we getting a different value? Okay, I encourage you to pause the video and see if you can figure it out before you watch me show you what the problem is. Okay, let me go back over here, and I think we're done with this. Shift F5 out of this and get that off the screen. Let me bring up our original chart here. First of all, we're now doing this multiplication. Okay, we weren't before. Remember, we had that special condition, we were doing an addition, and then we were starting the loop after doing 2 to the 1. We're now doing this multiplication, which means that our loop, remember, our loop's doing a multiply and an add. Our loop's doing two things, all right? This multiply and then an add, and a multiply and an add, multiply and an add. And before, the loop we had before was running an add, then a multiply, and an add, and a multiply, and an add, multiply, so on and so forth. So we were doing these operations and then these operations, like so. But now our loop, instead of doing the add, it's doing multiply add. So now we've grouped it up like this instead, and I'm not going to draw over this, but hopefully you see we're doing multiply add instead of add multiply. So now our one iteration of the loop is doing things a little differently than before. Remember, we started out at 2 to the 2, and now we're starting out at 2 to the 1. So that changed. Okay, and that's actually going to cause a problem, because when we actually get to 5, remember, we're incrementing our count. Every time we do the next power, we increment count to the next power. When we get to 5, we're actually not going to stop at 5. We're going to go all the way to 6. Okay, remember, we do a multiply and a plus, multiply and a plus. And then we do a compare here. 4 is less than 5, so we do it again, multiply and plus. And that actually means we're going to do our 2 to the 6th before our loop terminates. So let's actually draw that out down here. Oops. Well, yeah, let's get to blue. Let's draw that out down here. One more row. 2 to the 6th. And 2 to the 6th is 64. Which means we need to do 2048 plus 64, which is 2112, which is an 840 in hex. Hopefully that makes sense, that when you add 64, that gives you 4 16s, and so 840. Four up from this. All right, this is the number I expect to see in our ECX register when the program completes. Let's go verify that that's true. F10, Control Alt D, F11 to step into our code. Go down to the return, put the breakpoint here, hit F5, and the register ECX, I can't see it below my drawings, is at 640. 640. What went wrong? We have an 840. Debug it. Figure it out. But in the meantime, let me just show you what's wrong. Video's getting kind of long. We need to terminate this. We start our total out at 0, and if you step through and debug this code, you'll see that that 0 actually eats us up. Because what is 2 to the 0? Well, it's not 0. If I told you to evaluate 2 to the 0, and you told me 0, that would be incorrect, because 2 to the 0 is not defined to be 0. Anything to the 0th power is a 1. So we really should start ECX out, our running total, at 1, instead of 0. And you feel free to change the code back to how I had it, trace through and figure out why that causes a problem. You'll see very quickly that starting out at 0 actually vaporizes our total a little too early in the game. We don't want to do that by any means. Again, we're looking for the 840 when the loop terminates. So F11, let's build and run this. Control-Alt-D, step into our call here. Remember 840, the lucky hex number. I'm going to take that off the screen. Go down here to the return, put a breakpoint, watch ECX. I'm looking for an 840, F5. We're good. Okay, probably a little bit too dramatic for assembly language, but we're getting there. We're getting there. I think we've made this a little more elegant. We now don't have any special conditions. I can change the base all I want to. Let me get that off the screen. I can change the base to a 5, and that's the only place I need to change it. That's nice. I also get a result for 2 to the 0, which is 1. But again, no pun intended, this loop executes at least once. Alright, so if I ask you what is 2 to the 0, you'll actually tell me 2 to the 3, because here you've given me 2 to the 0, and then you figure out 2 to the 2 with the multiplication here, and then you add 2 to the 3, and then you check. Alright, how could you fix that? And then, more importantly, how could you fix that elegantly? I mean, you're probably tempted to copy and paste this code right here, and then maybe even, I don't know, paste it right here, except, you'd have to jump somewhere else. Anyway, bad. All right, there's got to be a better way than copying and pasting that code around. We want to avoid copy and paste. We've already had copy and paste, and in a future video I'll show you how to get rid of that copy and paste. All right, next video.